Thank you. I appreciate the invitation to come and give a talk here. And just about the practicalities, I'll be talking until 5, and then you'll have a chance to ask questions. I'll be sharing my screen, but you can also see my slides behind me. So I have a green screen here. I'm just putting the slides here. So you can either pin my video, or you can view the screens here. Up to you whether you like how you like to do it. And I hope that I'm now sharing the screen. It looks like I am. And I will just I'm also recording this myself. So if someone wants to get my stream, I will not be posting it anywhere, but just send me an email and I can share it with you. Okay, so I have the Zoom controls on my video, but that's okay. Let's get started. And Larry asked me to talk about convergent and discriminant validity. The reason for this topic is that this is I wrote a paper about discriminant validity. I published it last year in ORM, or just accepted like 2-3 years ago, and it has been collecting citations like crazy. So it's like at 200 or 300 now, 1 year since the publication. So it pushes up the ORM impact factor by about 1.5 or 2 for this year. And I'm really happy about the paper, and we really went into the topic of what exactly discriminant validity is. Before we get started, there's some resources that I prepared for you. And I have a YouTube channel where I teach mostly methods, but some entrepreneur stuff as well. And there's a playlist about discriminant validity. Some of these slides that I'll show here are on that playlist, and I plan to add the rest there. So if you want to have this content of this talk as short clips about specific topics, and maybe a bit more about some other topics related to the concept of discriminant validity, you can check the QR code here and go to my channel. So I don't receive any money for that. That's just no advertisement. I just do that for fun, and because I think it's a service to the community to post your teaching online. My talk today is going to be based on 2 papers. So I have this paper, Updated Guidelines on Discriminant Validity, that I wrote with Joe. I don't know how to pronounce his first name. And this is a very unusual collaboration. So Joe emailed me asking a question about my other paper, and he wanted to get my R code so he could run some simulations. And I shared the code with him, and then he told me that he can't get it to work and asked me to help him out. And I've never met the guy. I never talked with him. We only collaborated with email, because he said that he can't speak English and I can't speak Korean. He writes English really well, but he's not good at spoken English. So we just communicated by email. I have no idea what he looks like, for example. The other paper that I'm relying heavily on today is Carson and Herdman's paper on understanding the impact of convergent validity on research results. That's published 10 years ago, but I still think that this is the best paper on convergent validity that there is. So let's go through the agenda. What are we going to talk about today? I'm going to introduce you the topics of convergent and discriminant validity first. Then I'll talk a bit about whether and when or how convergent validity relates to reliability. This is something that I've been struggling with, because both reliability is assessed through correlations between similar measures, but convergent validity is also assessed by looking at the correlation between 2 measures. So when would a correlation be evidence of reliability, and when would a correlation be evidence of convergent validity? So it's the same correlation, and depending on the context, it can go either way, either reliability or convergent validity. I'll talk about that. That is a thing that most sources on convergent validity don't really address. Then I'll talk when would you need to report this. I don't think that every paper needs to report convergent and discriminant validity, but these are specific statistics for specific purposes. And so when would you need to report these? That's my third topic. Then I'll talk a bit about different techniques for assessing convergent and discriminant validity. And this mostly focuses on discriminant validity, because convergent validity is just a correlation. And then finally, I'll go through a workflow for discriminant validity assessment and how you could report this in papers based on our ORM paper. So let's get started. And introduction, my clicker ran out of battery, but I'll have the keyboard here, so that's not a problem. So introduction to convergent and discriminant validity. This there's a bit of confusion about these terms and what exactly they mean, and how exactly particularly discriminant validity should be assessed in empirical research. This is because of the history of these concepts. So these concepts or terms were introduced by Campbell and Fisk in 1959. And understanding the concept is important. The context is important because then you understand why there might be confusion. This paper by Campbell and Fisk did not provide any definition on what exactly discriminant and convergent validity mean. Instead, the paper explained different statistical tests that could be used to assess these concepts. All right, yeah, something weird happened. Yeah, the hardware is not on my side today. So I have the slide shown on TV in front of me, and the TV just cut off for some unexplainable reason. The original paper about convergent and discriminant validity used this thing called multi-trait multi-method matrix. And the idea of multi-method multi-trait matrix is that you are measuring at least 2 different traits with at least 2 different methods. And typically in empirical research, we want to say that X causes Y. So we measure X and we measure Y. But typically, we have just one way of measuring X, for example, a survey, and one way of measuring Y, for example, we might have firm profitability from some kind of database. And this causes a bit of a complication for assessing discriminant and convergent validity, because they were originally presented in this context that most of us don't now have. And there has been quite a lot of studies on thinking about what might discriminant and convergent validity mean in other contexts. And that takes us to the modern understanding of discriminant validity. So I and Joe, we went through papers that discussed discriminant validity, and there were basically a few different ways of how people understand it. Some people understand it as a property of measures. Some people understand it as property of constructs. Some people understand it as a correlation between construct or a result from a factor analysis, or some combination of these. And we started our paper by synthesizing one definition that would capture how researchers are currently using discriminant validity. So we presented this generalized discriminant validity, and it's a property of measures instead of constructs. And it is a measure, 2 set of measures have discriminant validity if the correlation between those 2 sets is low enough that we can conclude that they measure distinct constructs. So if we have 2 sets the idea is that if you have 2 sets of measures, or 2 measures that are too highly correlated, then it's implausible to claim that they would actually measure 2 different things. And discriminant validity is about this kind of assessment. So discriminant validity is about measures, it's not about constructs. So your items have discriminant validity if they are not too highly correlated. It's not the constructs that they are supposed to measure that have this property. And another important thing is that many studies present discriminant validity, or they define it in the context of a factor analysis model. We think that is too constraining, because you can assess correlations with other means, or you can have a nonlinear factor analysis model, for example, or a multi-level model, multi-level factor analysis. So we are not including factor model as a part of our definition, in contrast to many others. And then we present an operational definition. So if we have two scales, and if those two scales are, we construct some kind of composites, or we summary measures or latent variables from those two scales, then those latent variables estimated from two scales should not be too highly correlated. That is the operational definition, and that is what we would normally assess when we assess discriminant validity. Okay, now the question, of course, is that how much is too much? So what is low enough for two measures to be considered distinct? This depends on context. So, for example, if you have measures, you have constructs like gender identity and biological sex, they are correlated at 0.99 in the population or more. So gender and sex correlate very highly. And if we say that any correlation greater than 0.80 between two measures is problematic, then we would never be able to study these two constructs together. So we need to understand that there is no one rule of thumb or no one cutoff that works in every scenario, because sometimes your constructs are so highly correlated that your measures will be highly correlated just because the constructs correlate. It's even if the measures are completely valid, if the constructs are very highly correlated, then the measures will be highly correlated as well. Then there's another side, and this is that a reviewer raised during the process, is that sometimes items can be correlated to a low degree and still measure the same thing. And we came up with this example that if you have two thermometers, both measure temperature, but one is constrained to show negative numbers. So if it's below freezing, so I use centigrades. If it's below freezing, then this thermometer will show you the temperature. If it's above freezing, it shows you a 0. And you have the second thermometer, which shows only positive temperatures. So when it's above freezing, it shows the temperature. If it's below freezing, it shows a 0. These two thermometers measure two ends of the same construct, temperature, and they are correlated at 0.45. So a low correlation, on the other hand, does not mean that two distinct things are being measured. And this is important to understand, that discriminant convergent validity always have to be evaluated in the context. So there's no rule that says that if your items correlate at 0.8, then you have convergent validity. If they correlate at less than 0.8, you have discriminant validity. But you need to take these rules of thumbs to be flexible. And then if you can argue that the low correlation might still be acceptable because, for example, your items are calibrated to measure different parts of the values of the construct, then that should be taken into consideration. So the summary of discriminant validity are two measures intended to measure two distinct constructs have discriminant validity if the absolute value of the correlation between the measures is low enough for the measures to be regarded as measuring distinct constructs. So that is my summary. And in our paper, we present some general cutoffs. So this is the starting point. And as I said, take the context into consideration, but if you have nothing else that you could rely on, then you can rely on these cutoffs. So we reviewed the literature, and we concluded most researchers would say then that when two items are correlated at less than 0.8 after correcting for measurement error, there's no problem with discriminant validity. The items don't correlate too highly. If the correlation is between 0.8 and 0.9, most researchers would mention the correlation but not make a big deal out of it. And if the correlation is between 0.9 and 0.1, then that would be considered problematic, and it would need to be addressed somehow. And if two items are indistinguishable correlated at 1, then there is a severe problem with discriminant validity. But any cutoff is ultimately arbitrary, so take that into consideration. And there's also always, like if you measure gender and sex, the measures will be correlated, so these cutoffs will not apply.